We are on page 46 for today. We have one more sort of lens that we're going to use to view logs. We're going to talk about a couple different properties of logs that we can use to be able to rewrite them. We're going to see the terms expand and condense today. When we see expand, that's going to mean generally that we're writing more than one log, not always, but generally. When we see condense, that generally, not always, but generally, will mean that we're taking multiple logs and writing them as one. These are properties that we're going to need as we go into next week and we start talking about solving logs. So the last big section of this unit will be solving exponential equations and solving logarithmic equations. As we know, exponential functions and log functions are tied together because they're inverses of one another, and we can rewrite things in an exponential format as a log and vice versa. So having the ability to sort of combine or spread apart more complicated logs, or again, to combine simpler logs into a single log, is going to be a tool that we'll need for solving. So again, we are going to start on page 46 for today, and up at the top we have the properties that we're going to look at for today. The first one is called the product property. What the product property says is that if your argument is a product, if you are multiplying things together in your argument, you can actually separate those out into two different logs using addition. So instead of the log base a of u times v, you can write that as the log base a of u plus the log base a of v. And the same thing works forwards and backwards. So if you have two logs that you are adding together and they have the same base, you could combine them into a single log by multiplying their arguments. These properties work forwards and backwards. The quotient property deals with division. So if I have division in my argument, I can split that out into two separate logs using subtraction. I could also take two logs with the same base that I'm subtracting and combine them into a single log, or condense them into a single log. And then the last property that we'll use today is called the power property. So if my argument has a power, instead of having to deal with that argument having a power, what I can do instead is take that power and put it in front of my log as a coefficient. I can do the opposite as well. So if I've got 2 log base a of something and I don't want that 2 in front, one option that I have is to take that coefficient and rewrite it as a power on the argument. Okay, so each of these properties I can use forwards or backwards. If I go from something like this to something like this, that's called expanding. If I go from multiple logs down to a single log, or I go from a coefficient to now a power on a log, that's called condensing. Okay, so we're going to start with just some practice problems using these properties. So number 1, it says expand each logarithm. So that means I'm going to stretch these guys out. I want very simple arguments. That's the idea here for expanding, is I want the argument of the log to be as simple as it can. So for number 1, I've got division here, and then this guy also has an exponent. As we're starting off, I'm going to take these step by step. So the first thing I'm going to do, since I have division in my argument, is use that quotient property. So I could write this as the log of u to the 4th minus the log of v. And then I can continue by using my power property to take that exponent and sort of catapult it in front as a coefficient. So I'm going to take this guy and put him in front. So I have 4 log of u minus log of v. That would be my completely expanded log. For my first line of rewriting, I put parentheses around my arguments. If your argument is only one thing, you don't need the parentheses. Where my argument is more complicated, particularly for problems, we won't see these so much today, but for problems where I might be taking the log of x plus 1, like we saw for our graphing, if that 1 is part of the argument, I do need to put that in parentheses, okay? So this is my expanded log. I'm going to do the same thing with number 2. This time I've got multiplication, so I'm going to start using that product property. So I'm going to write log of x plus log of y to the 5th. And then I'm going to use the power property to throw this 5 in front here. So I would have a log of x plus 5 log of y. There's my expanded log. Number 3 is really similar to number 1, but this time it's that bottom number that has the exponent. That's okay. I still treat this exactly the same way. So it's the top minus the bottom. So log of x minus log of y to the 6th. And then we use that power property to bring that exponent in front. Only of the log that has the exponent. So notice the 6 doesn't go in front of this guy. It only goes in front of the log that has that exponent. For 4, I've got multiple things inside my log, more than 2 things this time. That's okay. I treat it exactly the same way. So this would be log of x plus log of y plus log of z squared. And then again, I'm going to take that exponent and just sort of catapult it in front like a coefficient. As I'm expanding these logs, I'm doing this sort of using one property at a time. As you guys get better at this, as you've had more practice, if you can go straight from here to here, that's absolutely fine. I'm doing this step by step as we're starting. For 5, this time my exponent is outside of those parentheses. That means that this exponent applies to both a and b. So this would be like the log of a squared times b squared. Since that exponent is outside of parentheses, it applies to everything inside those parentheses. So when I go ahead and start expanding this, I would have the log of a squared plus the log of b squared. And so in this case, my exponent, since it applies to the arguments for both logs, will be a coefficient for both logs. So I would have 2 log of a plus 2 log of b. And I see something similar with number 6 here. So I've got the log of the square root of x times y. So our exponent properties are going to come into play here as well. Remember, if I have a root, I can write that as an exponent. So this would be just like the log of x times y to the 1/2 power. And as we saw with number 5, when I've got that exponent outside of parentheses, it applies to everything inside. So this would be the log of x to the 1/2 times y to the 1/2. So I can expand this using the product rule, log of x to the 1/2 plus log of y to the 1/2. And then I'm going to use the power rule to put the exponents in front as coefficients. So 1/2 log of x plus 1/2 log of y. Questions for me so far? Depending on the setup of my problem, it might be to my advantage to have a very simple argument for my log. Depending on the setup of my problem, it might be to my advantage to have just one log. That's why we learn these properties and we practice them both ways. At the bottom of page 46, we're going to look at what's called condensing these logs. So condense means shrink it down to just a single log. The argument might be complicated and messy, but that's okay. The idea is we only see one log. Okay? So for number 7, I've got the log of something minus 2 times the log of something. So since I've got a coefficient for this log, that means this guy can go up here as an exponent. So I would have the log of 7 minus the log of 12 squared. And again, I'm doing these very step by step. The more we practice this, the more that you do, you'll be able to do them faster and maybe even combine some of these steps. And then the next thing I notice is that I'm subtracting 2 logs that have the same base. For the logs that we're working with on page 46, they're all, except for number 9, base 10, because I don't see the base written. It doesn't matter what the base is as long as it's the same. So if they were both log base 3 or log base 7 million, doesn't matter as long as the base is the same. Now I've got subtraction, so I'm going to rewrite that as division. Remember, it's the first thing is on top and the second thing is on bottom. So I would have the log of 7 divided by 12 squared. If you want to write your 12 squared as 144, that's fine too. So I could also represent this as the log of 7 over 144. For number 8, I've got 3 logs here. That's okay. The first 2 I am adding. So I'm going to multiply these numbers together. So this would be the log of 2 times 12. The last log I'm subtracting, so this argument I'll divide by. And then again, since we're dealing with actual numbers here, if I want to tidy this up, I can. On the top, 2 times 12 is 24. And then 24 divided by 4 would give me 6. This is just the log of 6. For number 9, I have natural logs here. Since they're both natural logs, I can condense them the same as I did 7 and 8. I've got a coefficient here, so I'm going to throw that up as an exponent. So this would be the natural log of x minus the natural log of y to the 4th. Subtraction, I could rewrite as division within the argument. So it will be the first thing divided by whatever I'm subtracting. So this is the natural log of x over y to the 4th. For number 10, I'm adding 2 logs together. Both of those logs also have coefficients. So I'm going to start by writing those coefficients as powers. So this would be the log of u to the 6th plus the log of b cubed. And now logs that I'm adding, I can condense by multiplying their arguments. So this would be the log of u to the 6th times b to the 3rd. There's my condensed log. Questions for me so far? Okay. There are some practice problems on page 47 that we are going to skip over for this second. And I want to hop to page 48. Page 48 has some more log property practice problems. We're going to go through the odds together. So on page 48, we're going to start with number 1. For some of these, you'll notice we have a base written there. So as we expand these logs, it's important that we include that base for all of them. So for number 1, this says log base 2 of 8 times m times n. So I'm going to rewrite these using that product property. I'm just going to expand this by splitting all of these pieces up. So log base 2 of 8 plus log base 2 of m plus log base 2 of n. Now, log base 2 of 8 is an example of why I might care about expanding logs, why I might want to spread some of these logs out. Log base 2 of 8, since we have all values here, all numbers here, this, remember, means 2 to the what would give me 8? Well, 2 cubed. So log base 2 of 8 is actually just 3. So if I can expand a complicated log, something with kind of a messy argument, if I can expand that and get just numbers out of it, that might be a reason why I want to expand a log. So this simplifies to 3. And then I've got variables for my arguments for the other 2 logs, so I can't do anything else with them. But I was able to simplify log base 2 of 8. For number 3, this root here, remember I could write as a 1/2 power, that's just for n. As I expand this, I would have log of 10 plus, I'm going to handle this in one step here, so the exponent's going to come in front, 3 log of m plus, again, that exponent will go in front, 1/2 log of n. Now, log of 10 is also something that we can simplify. When I don't see the base, that means it's 10. So this means 10 to the what power gives us 10? Well, 10 to the 1st. So this log of 10 is actually just 1 plus 3 log of m plus 1/2 log of n. Number 5, our directions say condensed. So we're going to take all these logs and write them as a single log. I see ln here, so that means I've got a natural log. And I'm going to have just one argument here. M plus n means I'm multiplying those things together. And then I'm subtracting p, so I'm going to divide by p. I'm also subtracting q, so q will also go on the bottom here. Now, what I do not want to see is you give me in an argument log of m times n divided by p divided by q. This is not good math grammar, okay? We don't have a like triple decker fraction, okay? It's not a cake. Don't give me that many layers, okay? 2 is okay. Don't give me this. Number 7, another condensed one. This time I've also got some coefficients that will pop up as exponents. So this will be log of m squared. Since I'm adding, this will be multiplication. And then n to the 5th. Nine, we're condensing again. So I'm going to write this as a single log. We've just got subtraction here, so I'm dividing the arguments. Log base 3 of m divided by n. And then number 11 here, remember that this root we could write as a 1/2 exponent. So I'm just going to rewrite this bottom here. This would be 2 to the 1/2 times n. Since n is not under the root, n does not get the 1/2 power. So as I rewrite this, this would be the log base 4 of 8. Since I'm multiplying by m, it would be plus log base 4 of m. And then I'm dividing by this stuff on the bottom, so I have to subtract. And I'm going to run out of room on this line here, so I'll wrap around in just a second. I'm going to subtract log base 4 of 2, but since it has that 1/2 power, that 1/2 will be my coefficient in front. So log base 4 of 2, and then minus, since I'm also dividing by n, minus log base 4 of n. Questions for me so far? So as we work through this sort of second set of practice problems, I did multiple steps at once. If that is too much and you want to take it step by step like I did for the original practice problems, that's absolutely okay. So if you need to write out this with the exponent first and then throw it in front, that's totally okay. The last thing I want to look at is our last odd problem on page 48, number 13. It says, which of these is not correct? So what we have for each of these is log base 2 of 24, and I have it equal to some expanded version. I want to know which of these is actually a correct expanded version. So to figure out which of these is a correct expanded version, I'm actually going to take what they've given me and condense it down and see if it matches log base 2 of 24. Now, the really first thing I'm going to look for is these are all log base 2 of 24. Are these parts all log base 2? And they are. If I had anything that had a different base, I could throw that out. But they kept the same base for all of these. So I'm just going to look at, as I rewrite all of these, would I get back to log base 2 of 24? Okay. And again, I'm looking for which one is not correct. So I would expect for many of them, I'd be able to do this rewrite. Since I'm adding these logs, to condense it, I would need to multiply their arguments. So I would have the log base 2 of 6 times 4 here. Is 6 times 4 24? So this one's okay. For B, I've got, if I condense, 72 divided by 3. 72 divided by 3, does that give me 24? It sure does. That one's okay too. For C, This would be, if I condensed it, log base 2 of 8 times 16. Is 8 times 16 equal to 24? No. So this one is not correct. Let's check these. So this would come up here as an exponent. So I would have log base 2 of 2 squared times 6. So 2 squared is 4, and we already said 6 times 4 is 24, so this one's okay too. Just see there, it was incorrect. Questions for me on our log properties? Again, these work both ways. When I take multiple, when I take a single log and spread it out across multiple logs, or maybe take a power and throw it down as a coefficient, that's called expanding, okay, like we did here and here. When I take multiple logs and coefficients and throw them all inside the argument, that's called condensing, like we did here and here. So make sure you watch your directions carefully so you can see what way you're trying to go. For the rest of class, I would like you to work on the remaining problems on page 48, as well as the problems that we hopped over on page 47, okay? So page 47 and finish page 48.